Alright guys, welcome back. We're reintroducing videos. We're at chapter 7.1. As always, here's some vocabulary presented for you guys so you can toy with that leading up to this quiz and subsequent exam. Okay? Here's some very valuable notes regarding exponential functions. I'm going to cover the basics. So basically a lot of situations in the real world are modeled after exponential functions, so let's cover the basics. Okay, the parent of an exponential function f of x equals base b raised to exponent x. Right? Very important, b must be positive. B cannot equal to 1. And how do you know if you have growth or decay? You look at the base b. So long as you're larger than 1, you're okay for growth. For decay, very important, still b must be positive. Remember, b cannot equal 1, so it must be between 0 and 1. Okay? Additionally, in this context of exponential functions, you can have a constant percent decrease or increase. What you want to pay attention to, maybe take notes on, is this here is the initial amount. Here, as is being indicated, this is the decay factor, 1 minus r. Or if you have plus r, you'll have the growth factor. Here they have t. Okay, many times we're going to switch t for x, which will basically describe the number of periods. And then you have the total amount at time t, or after x periods. Alright, so definitely worth having this in your notebooks. Alright, so this one says tell whether the function y equals 2 times the quantity 5 raised to x shows growth or decay, then graph the function. Alright, if you have good notes, this here is the base, not the initial amount, and this is going to indicate whether you have growth or decay. So, as a reference, I'll notice that so long as b is greater than 1, I have growth. So I'm gonna circle growth there. Okay, it says graph. That shouldn't be too bad. Although you can be manual, maybe create a table on paper and use the graphing feature of the calculator. Alright. And I do notice I don't have the greatest window, so I'm going to hit menu, window, and I'll try zoom fit. Okay. So it gives me a better view of what I'm looking at. Let's go ahead and kind of jot this guy down here. Okay, and I'll transfer the image this way since I am being asked to graph it. Okay, so everything's done. Let's go move on. This next one says Miro bought $300 of free range wireless stock. So FYI, we got some story problems coming. In January of 1998, the value of the stock is expected to increase by 7.5% per year. Use a graph to predict the year the value of Miro stock will reach $700. Alright, so let's kind of highlight some things here that are important. Right, the year is important, this 300, but the most important thing here for me is this whole increase. Alright, so I'm going to once again reference my notes, and here we've got the formula that describes increase in general. Okay, so I'm going to transfer that over. Once again, they're using t for time because the calculator operates in terms of x and y. I'm going to switch t for x. Okay, so let's go and do that right here. We were given a of t equals what? A, the initial amount, 1 plus r, the rate, okay, do here real quick is switch the notation, and I'll even go as far as to go f of x because it what matches the calculator. Okay. Alright, so the next thing we got to do is simply substitute. Alright. So if I'm being asked for A, the initial amount, you can pause the video and guess, but the answer is 300. We got the 1 plus. The rate, okay, it's presented as a percentage, but from experience you know to translate the decimal to units. Okay, which puts us in this position here. Okay. So this is the formula that applies to this story problem. What else do they need here? Use a graph to predict. Okay, so now we're going to take this information. We hit tab real quick here. Go back to the graph. Alright, so I'm going to remove this first function we dealt with and move on to this second one here. Okay. Alright. The next thing I want to do is adjust the window, so I'll hit menu. I'll hit zoom fit. Okay. So let me go back to the problem. It says use the graph. We now have the graph to predict the year the value of mirror stock will reach $700. So again, the year, right? This is the number of periods per year, and ultimately the Y value is the monetary value. So let's go ahead and go to the calculator. Okay. What I'm going to do here is I'm going to introduce the trace feature, menu 5, 1. Okay. And as you can see, I have now coordinates the x value and the corresponding y value. So I'm going to keep on moving to the right until I get close to that $700 value that they're interested in. And I'm very close here at 11.7. And then I get to 12 years, and I overdid it, so I'm going to go back to about 11.7 and estimate roughly, I don't know, 11.8 maybe. Okay. So let's come down here, and then I'll make a comment here at approximately 11.7, we'll say 5. We've got what? Mirror stock will be approximately $700. We've got the $700 that they're interested in. Okay. Alright. Let's continue here. This one says a bacteria population starts at 2032 and decreases at about 15% per day. So, just from experience, decrease is going to be very important. Write a function representing the number of bacteria present each day. Graph the function, and after how many days will there be fewer than 321 bacteria? So there's a lot going on here, but we've got some experience. So first, let's go and address this decrease. Find the right formula. Okay, this one's gonna go and work for us in this case. So let me transfer it over. Okay, I'm going to copy it exactly as is given. 1 minus RT. I'm going to introduce the x instead of t. I'll exchange the a for an f of x, a little more comfortable for us. I guess from here we can start plugging away. So f of x equals our initial amount. In this case we've got 2032. We next have 1 minus, what is it, the 15%, so we'll put 0.15 to the x. Let me just look at the previous problem. Okay. The one thing that I could have done here that might play a role down the line with you guys is simplifying the math in here, so I'll go ahead and squeeze it in the last problem, just in case it can help prevent somebody from making a simple mistake. Okay, so you can simply add this quantity inside the parentheses, and that's exactly what I'll do here. I take time to do it here because it can trip you up if you don't see that value, okay? Condensed or simplified. So this one is 0.85. Of course, they're equal to each other. You'll get the same answer, but it's nice to appreciate the different look. Alright, so let's go back to what they asked for. Write the function, done. Graph the function, so let's move on to that one. It seems like I'm graphing some G for some reason. I'll move past that. Okay, so this is our focus. Let me go and unselect the previous one, and here's where we're currently at. Again, one feature that you want to take advantage of is the window zoom fit, just to kind of maximize the window, okay, for your graph. What did they ask for? They want it graphed, so let's go and take time and kind of capture an image of that. Let's see here. Alright, that'll work. What else did they ask for? After how many days will there be fewer than 321 bacteria? Okay, so once again, it's good to remember that x is the number of periods, or essentially t time, right? So after how many days? 321 bacteria. So this half of x would represent the total number of bacteria, unlike this number that was the initial amount. Alright, so let's go back to the calculator and take advantage of the trace feature. Okay. Once again, you'll see that down here on the bottom right we have x and y coordinates. This is telling you we've got a very small value, so let's go ahead and just kind of head towards the right here. I'm looking for a y value and f of x value of what, 321? Getting closer. Okay, so notice what just happened here. From about beyond 11.1, I press into that territory, so I'm going to make a similar statement. So as long as you're beyond that 11.1, we could say at about x equals 11 point, let's say 3. What is it asking for? And then we've got what? Our y. Let me go back to the question. Will there be fewer than 321? Our y is less than 321. Okay. All right. Let's go back here real quick. And I'm going to edit this statement here so that it's more consistent with this last one we did. So we'll reach $700. Okay. So at X approximately 11.75. Let's see what I wrote down here. Then y is in this case equal to roughly, I should probably say roughly 700. Okay. So by the way, this is a notation that we'll work with moving forward. All right. And lastly, we have an initial investment of $10,000 grows at 11% per year. What function represents the value of the investment after 2 years? All right. I don't have to look back anymore. I'm pretty good at this now. The last two problems. Okay. Question is, why am I jumping the gun here? Because it says grows, right? Or growth. I'm going to substitute. Okay, this is just some generic name for A for amount. I'm going to turn it into something more user-friendly in terms of calculator. I don't have to, but it's a good practice. Alright, and now let's go ahead and plug in. F of x equals, I need an initial amount. Okay, initial investment times 1 plus, what are they saying, 11%. In this case, I'll toss in the 11% just for the heck of it. Now I'll go and make the appropriate adjustments and kind of wrap it up here. We've got the 11% as 0.11, and lastly, we can write that as 1.11 raised to the x. Okay. What did they ask for? A function? No. We've produced one. We've given it to them, guys. Thanks for your time. I'll see you guys in class with questions and comments.